I'm going to go over a quick tutorial on how to read energy diagrams in chemistry. So, an energy diagram that you might encounter might look something like this. We have a y-axis here where we're representing potential energy, and we have a reaction coordinate here where we're just looking at the progress of a chemical reaction. And we start off with some reactants, and we're ending up with the formation of some product here. From an energy diagram, we can determine which products are kinetically favorable versus which products are thermodynamically favorable. So kinetics basically refers to how fast a reaction is happening. And if we want to determine the kinetically favorable product, we look at the activation energy here. So the activation energy from these points here. Now, we can tell that a product is kinetically favorable if the activation energy is pretty small. But if the activation energy is pretty large, then it wouldn't be kinetically favorable. On the other hand, we might want to determine the thermodynamically favorable product. And to do that, we look at the delta G, or Gibbs free energy, which is basically just the difference between the energy of the reactants and the energy of the products. So if a product is thermodynamically favorable, then delta G will be really, really big. And delta G will be really, really big because the energy between the reactants and products, there's a large difference between them. So the product should end up at a very low energy level, which is a more stable product. So to give a little example, we might have a reaction energy diagram that looks like this, and we have two possible pathways for A and B. A and B can form products C plus D, or A and B can form products E plus F. And if we are given the question to determine which products are kinetically favorable versus thermodynamically favorable, how would we do that? So let's look at kinetically favorable products first, right? So to determine the kinetically favorable product, we look at the activation energy. The blue curve has this activation energy, and the red curve has this activation energy. The activation energy here is much smaller than the activation energy here. So the formation of E plus F will be the kinetically favorable product. Now, to determine the thermodynamically favorable product, we look at the difference in energy between the reactants and the products. So for the blue curve, for the formation of E plus F, we have this difference in energy. And then for the red curve, for the formation of C plus D, we have this free energy level. So based on that, we see that C plus D ends up at a much, much lower energy level than E plus F. So that is the formation of a more stable compound. So we'd say that C plus D is a thermodynamically favored product. So we can also determine the transition state and intermediate from an energy diagram. Transition states are molecules that are formed when bonds are in the process of being broken or formed, and they're located at local maximums. So these points here would be the transition state. An intermediate, on the other hand, is just an unstable molecule that is formed in between the reaction as we're forming products from reactants. And intermediates are located at local minimums here. So we'll also go over the Hammond postulate. The Hammond postulate basically states that if two molecules have similar energy levels, then they will be structurally similar. So using this principle, we can make a generalization about the structure of a transition state in an exothermic process or an endothermic one. So in an endothermic process, we have the transition state here, and we have the reactants here. The reactants and the transition state have very, very similar energy levels. So in an exothermic process, the transition state will be structurally similar to the reactants. In an endothermic process, we have the transition state here and the products here. They're very, very similar in energy. So in an endothermic process, the transition state will be structurally similar to the products. But yeah, okay, that is my lecture for today. Basically how to read energy diagrams, how to determine which products are kinetically favorable versus thermodynamically favorable, how to identify transition states and intermediates in a reaction in an energy diagram, and then how to determine like the structural similarity either to the products or the reactants in an exothermic process or an endothermic one. But yeah, that's it for today. Follow, like, subscribe for more content. I will be posting more videos about chemistry and probably other subjects once I get to that. But yes, follow, like, and subscribe for more.